In this video, I'm going to explain the concept of a well-formed formula, which is pretty simple, and then I'm going to get into some examples. But first, let me give you an analogy from natural language. What gives a sentence its meaning? Well, a good candidate here would be words, right? I mean, words have their own meaning. They go into a sentence and then they give that sentence its meaning. And yet, is it just words? I mean, consider the following sentence: runs, jumps, walks. Sentence? Meaningful? Well, not really, right? I mean, what could that mean? What's the problem here is that we have words, but we don't have the right kinds of words. We have three verbs and no subject. And that means that even though it is a string of words just like any other sentence, it doesn't have that meaningfulness that a regular sentence would have. It's nonsense. Now, let's say I get that subject that I was missing in the last example. Runs, Jeremy, walks, jumps. Now I have the right components, right? I have the subject and I have verbs. Well, no, there's still a problem here. The thing is, these need to be in the right order. It is true, by the way, that in Latin, word order is a lot more free. I mean, you can break up words that seem like they should be going together and all kinds of crazy stuff. But even in Latin, there is some order that you need to follow. So, to make a sentence in language, we need the right components and we need the right order. Well, logic is actually very similar to a language. In fact, people will call it a formal language as opposed to a natural language. Things like Spanish and English, things that we would use in everyday situations, that is what people will call a natural language. Whereas, of course, logic we call a formal language. What's the difference between the two? Well, one thing is that the rules of grammar, the rules of natural language are very malleable. So, for example, my favorite team is the New Orleans Saints, and we have this, I don't know if it's not really a saying, I guess it's a little chant, who dat say they're gonna beat them Saints? Who dat, who dat? Imagine, or consider that phrase, who dat, right? Really, it is supposed to be, who is that? Who is that says they are going to beat those Saints? So, this new formulation drops the verb, right? Who dat is missing the verb is. It's grammatically incorrect, right? But you understand it, right? I mean, you're not sitting there like, wait, there's no verb here. What is he doing? In other words, communication still took place even though it's grammatically incorrect. Now, the goal of natural language is communication. And notice that who dat is actually shorter than who is that. So a person that uses the term who dat and succeeds in communication is actually going to be more efficient in using natural language than a person who is saying, who is that? Now, it's in ways like this that grammar is constantly in flux. At first, we say, no, that's not grammatically correct. People say it long enough, and all of a sudden it becomes acceptable grammar, right? For example, the word can't, right? It was really cannot, but people said it fast enough, it turns into can't, and then it just becomes accepted. Another one in California, everybody still says for sure, right? People think that we talk like that. They do talk like that. It's really weird. My wife is actually from Albuquerque, and she came here not with a strong New Mexican accent, but with a New Mexican accent, and she now will say for sure. But notice, it should be for sure, and that for sure is actually slower to say than for sure, right? It's almost like we're not even putting a vowel in there. But again, the goal is communication. And when we start saying that to each other, everybody knows what we mean, right? So we start saying that, we can speak faster, and all of a sudden it becomes more helpful to speak in this way. However, formal language is not the same way because formal language doesn't have the same goal. Natural language, we said the goal is communication. Formal language, the goal is more of precision. I mean, there is an element of communication there, but really what you want to do is to be precise with these languages. That's the whole purpose of them being invented. Otherwise, we would just stick with natural language. So the rules in formal language are a little bit more rigid than they are in natural language. It's not a matter of just however people seem to be speaking or however they just happen to naturally develop. No, we make sure that we write down the way things should be said. And we can change those rules, and we can even change them to make ourselves more efficient, but not without being clear about it in our rules. Not without saying in our rules, here is how we are going to speak in this language. This is why, even though a well-formed formula is very analogous to a sentence in natural language, we don't actually call it a sentence. A well-formed formula is just a string of symbols that counts as part of a formal language. Just like some strings of symbols in natural language don't count as sentences. They're not part of that language. If you're not a well-formed formula in that language, then you're not part of that language. And by the way, people will often shorten this to WFF, either in caps or in lowercase, and sometimes people just call them formulas. To get a little more precise understanding of what exactly it is that we're talking about, let's go ahead and compare a well-formed formula to a sentence of natural language. Well, the first thing to note is that a lot of what counts for a sentence in a natural language has to do with use. Wittgenstein would say it all has to do with use, but maybe we'll just curtail that to at least a good deal of it. Whereas in a formal logic, everything about what counts as a well-formed formula has to do with the rules. In fact, in the last video, we saw how you could list out an entire syntax. You start off with those acceptable symbols, with the symbols that we're going to use. We had the symbols for all the basic propositions, all the connectives, and the only 2 punctuation marks that we'll have. And then we listed that set of rules. Now, using that set of rules on how we can combine these different symbols, how it's acceptable to combine these different symbols, we get all of our possible well-formed formulas in this formal language. If, by the way, you're like, well, how can you get all of the well-formed formulas? In the next video, I'll talk about how this definition works as a recursive definition or an inductive definition. But that's next video. So we generate all of our well-formed formulas using these rules. If it's not using these rules, then it doesn't count. But think about that. In grammar, in natural language, really grammar is descriptive, not prescriptive, right? It says, here is the way that we more or less seem to see as acceptable in our communication. We kind of put these words together in this way. And if we don't, then we say that it's grammatically incorrect. But even then, you can use sentences, you can use them as sentences, even when they're grammatically wrong. I can say something like, say it ain't so, and that sure sounds like a sentence. It sure acts like a sentence, even though it's not grammatically correct. But unlike sentences, if it doesn't follow the rules that we've laid out here in our syntax, then it is not a well-formed formula. A second difference is that a formal language is really nothing but the collection of well-formed formulas that make it up. Whereas the set of sentences that count as part of a language is pretty vague. And I mean that term vague in a very philosophical sense. I mean, consider this. When did Latin become Spanish? I'm not sure if you're aware, but all the Romance languages like Italian and Spanish and French and Portuguese, Romanian, all these languages began as Latin, and the Romans, hence Romance languages, the Romans went out, conquered all these places, and Latin was spoken there, and yet after enough time elapsed, the Latin that they spoke in those different places changed so much that they just called it a new language. So when does it count as Latin and when does it count as Spanish? Now consider a moment in that kind of transition period where we're changing this language from Latin over to Spanish, in some long period of time. What counts as a sentence in each language is probably going to change, right? I mean, you're going to be using words that function in one language, don't function in another language, but somewhere in the middle there, it's going to be kind of mixed up. So what counts as a sentence in a language is not going to be very rigid. Now, I said it was vague as to when one language becomes another language, but when does one logic become another logic? Anytime that a well-formed formula is changed. Anytime you decide you're going to use a different symbol. Anytime you decide you're going to use a different rule. The thing is, in your formal language, the whole thing really is just that set of well-formed formulas that you are accepting that are going to be usable in your language. You change one of those rules, you change one of those symbols, all of a sudden we got a different formal language. Another difference here is that aside from the logical symbols, which get their meaning from the definition you just give them, the meaning of the well-formed formulas really derives from your glossary. You have to sort of set out ahead of time, I'm going to have A stand for all aardvarks are awesome. I don't know. Whereas sentences are spoken by a speaker in a context. So that's sort of where they get their meaning. They don't get their meaning from some written out, like, this is what we're going to mean by this, right? It's sort of like, depends on who's saying it, depends on where they are, it depends on how they're saying it. All those kinds of different things go into filling in the meaning of a sentence. And a final difference between well-formed formulas and sentences, or at least a final difference that I'm going to give, is that we string these well-formed formulas, once they're created, we string them together to evaluate them for validity. before we even figure out what they mean, before we put any meat on the bones, before we say this is what this propositional parameter stands for. We string them together, we see, is this a valid argument or not? Now, you can't do that with sentences of natural language. It makes all the difference in the world what those words mean. You can't put just meaningless, empty words up all next to each other and say, do these fit? In formal language, in a well-formed formula, it's much like math. We say something like 2 plus 2 equals 4, correct, but you could ask 2 whats and 4 whats. What do these things mean? We can still evaluate whether the math is correct or not, even though we haven't put any meat on the bones. Same thing with a well-formed formula. We can evaluate whether or not we have a valid argument, even if, especially apart from the meaning of the propositional parameters. So now that we have a better understanding of what a well-formed formula is, let's go ahead and do some practice at identifying them. We're going to look at our syntax. We're going to look at some practice problems, and we're going to see, do the practice problems follow the syntax in order to make a well-formed formula? I asked you to do 2.5.1 exercises question 1, which says to state whether each one of the following is a well-formed formula of propositional logic. Number 1, we're given parentheses, A arrow B. Now, let's look at our rules in the syntax. First, I know that A and B are each separately well-formed formulae. I know that because that's rule number 1 that's set out there in the second part of our syntax. Now, by the second rule in our syntax, I also know that stringing 2 well-formed formulae with an arrow between them and parentheses on either side is also a well-formed formula. Sweet. What about adding that last parentheses around the whole thing? You have parentheses A arrow B and parentheses, and then you throw another one on the outside of that. Is that okay? It seems harmless enough, right? But look at our rules. Do we have any rule that says if alpha is a well-formed formula, then alpha with parentheses around it is a well-formed formula? No. And since the third rule says that nothing else is a well-formed formula, that means that this is not a well-formed formula. So even though you would understand what somebody meant if they wrote this, this would not be part of our formal logic. Number 2, you could see the A arrow B, right? The double arrow. Is that a well-formed formula in our logic? Well, look at our syntax. I know that A is a well-formed formula. I know that B is a well-formed formula. I know given those 2 well-formed formulae, I could put A arrow B and that would be good. But there's no rule in here that says that you can go A arrow B. So this is not a well-formed formula. Look at number 3. We have the letter A. I know that A by itself is a well-formed formula. Now look at that inside parentheses. I have a parentheses and A arrow A parentheses. Rule number 2 says that if alpha and beta are well-formed formulae, then alpha arrow beta is a well-formed formula. And again, I'm not mentioning the parentheses all the time because it gets very tedious. Remember that alpha and beta can stand for any well-formed formula, even the same one, right? So even though we have an A in one slot and an A in the other slot, the same basic proposition, this is part of this is still a well-formed formula. Parentheses A arrow A and parentheses, we're good. That's a well-formed formula. Now look at the outer arrow in parentheses, right? We have an A, I know that's a well-formed formula, an arrow, and then I have the A arrow A, which again, I know is a well-formed formula. According to rule 2, this is also a well-formed formula, right? I have my alpha is A, my beta is A arrow A, well-formed formula. Number 4. Well, in this one, I have that parentheses, A arrow A, end parentheses, which I had from the number 3. So I know that part is a well-formed formula. I know that guy is good. And I know at the very beginning of this, that A, I know that's a well-formed formula by itself. It's a basic proposition. Rule number 1 covers that. But then I have that second parentheses around that parentheses A arrow A, end parentheses, right? I had that second parentheses. At number 1, I figured out I couldn't do that, right? I look at this list of rules and I see that I can't take a well-formed formula and just throw it inside a set of parentheses and now I have a new well-formed formula. That doesn't count. So this is not a well-formed formula. And notice the difference between 3 and 4 is just that beginning parentheses being moved over a little bit. Number 5 just looks wrong, right? I know A and B are both well-formed formulas. I know that parentheses A and B, right? I know that that is a well-formed formula. I know that A by itself is a well-formed formula. But the fact that I have that and parentheses A doesn't match up with any of my rules in number 2. So this is not a well-formed formula overall. Number 6. Now this one is a little bit more complicated. I see that A, and I know A is a well-formed formula. I see that A and A inside of that parentheses, the last 2 A's, you know, and that checks out with number 2, with rule number 2, right? That's a well-formed formula. And then looking over to the left one, you know, I have that A and A. Well, that A over there is well-formed formula. I have the and then I have my well-formed formula A and A, right? So that's a well-formed formula. And then I take that and I have the A and A. Well, so every time that you go out, you still have a well-formed formula. The trick here is, though, that you, at the very end, this is kind of dumb, but at the end you have to count the parentheses. There are 7 beginning parentheses and there are only 6 end parentheses. So this is not a well-formed formula. Kind of silly that you have to count them, but there you go. Number 7 is just all kinds of wrong, right? I already know that you can't go double parentheses. I know that that's not valid. And notice that doesn't mean that you can't have parentheses next to each other like we had in number 3. You know, at the end of number 3, we have 2 parentheses next to each other. I also see the and or in the middle. And I look at my rules here, and in no rule do I have, you know, you can put an and or and then well-formed formulae outside of those. So I know that's wrong too. Another question you might have is, what about putting those propositional parameters right next to those basic propositions right next to each other, right? What if I just had AA or even parentheses AA and parentheses? Well, again, look at your rules. Is there any rule there that says that you can do that? No, so that's wrong too. Now the thing is, we did say in an earlier video that some people do conjunctions like that. Instead of saying the A with a caret A for A and A, they just put 2 A's next to each other. Some people do that. However, notice that in our syntax, we did not say that that was okay. It would be fine if we wrote that in our syntax, but we didn't write that, so that's not part of our formal language. And number 8 is doing a whole lot of the same stuff, right? We have the double parentheses, we have the B and the C right next to each other. This also is not a well-formed formula. Number 9, you have that A, B, C, and like I said earlier, you can't just put 2 propositional parameters right next to each other, 2 basic propositions right next to each other. That's not part of our syntax, right? Or I should say that's not a rule in our syntax, so it's not part of our formal language. And number 10 is probably the most complicated of all of these. Of course, as we said before, A is a well-formed formula. We also have a parentheses A or A. I look at rule 2 and I see for that or, right, that is set up correctly, parentheses A or A and parentheses. So that's a well-formed formula. And then within parentheses, I have that A or A, I have an and then I have the A. That is a well-formed formula, an and then another well-formed formula. That altogether is a well-formed formula. And then next to that, I have another A or A, an and then, you know, this one that we just saw, and that's all encompassed in a parentheses. So that's a well-formed formula. And then next to that, I have another and an A or A on the other side of that, right? I have a parentheses, an A or A, I have an and then I have all that mess that we just said was a well-formed formula and an end parentheses. So all this together is actually one good well-formed formula. We're set on this one. That's it for the well-formed formulas. If you have more questions on exactly what one is, please hit me up in the comments. We've only done 2.5.1 exercises question 1. For next time, go ahead and do question 2, and we'll talk about what is a recursive definition.